Good afternoon, students. We'll continue with our today's lecture. So in the last lecture we had completed deadlock detection with multiple resource of each type. So how it is denoted? It is denoted by a matrix. And what are those metrics? There are two metrics which are being compared, that is current allocation matrix and the request matrix. Now how does the algorithm for that multiple resource work? So they have taken an integer w as an integer for an array of length m. So there will be multiple values. So the array is for variable length values, and those values will be calculated in length m with the help of integer w is equal to length m. That can be 10 values, 15 values, 45 values, anything. Initialized array A, available number of resources. They will compare the resources, that is, this is the available number of resources and these are the resources which are actually in total there. That is, from the union they have these many number of arrays which are available. F will be the boolean array numbers, that is length n, initialize to false, that is determine if process finished or not. So these will determine, the boolean arrays will determine that even if the process is complete or not, they will get added to the available number of resources. Here find an I such that, so how is the function existing? I will not go with this, I will actually explain you from the book and then I will go to these values. So f of I is equal to false, that is pi is currently not involved in the deadlock. Pi means for which unmarked processes are not involved in the deadlock. They are only just going with the values. So then fi is equal to false, therewise fi is equal to true. So these are the conditions they can occur, that is c of I is not equal to 0. Then if c of I means what? I is the row of r means the requests, and a is equal to the array of values. So if f of I is equal to false, r of I is less than equal to w. So the integers will be less than equal to the request which are there. If no such I exist, then w is equal to w plus c of I. F of I is equal to true, then f of I is equal to false for sum of I. Then the system is in a deadlock state. Means if f of I means my boolean values are not yet released or finished, what will happen? It will then there will be a deadlock state, because there will be no other resource which will be provided. Then deadlock detection with multiple resource of each type means what? Suppose if I have E as 4, 2, 3, 1, that is tape drives, plotters, scanners, CD-ROMs, and A is equal to 2, 1, 0, 0. So the current allocation matrix is 0, 0, 1, 0, 2, 0, 0, 1, 0, 1, 2, 0, and your request matrix is 2, 0, 0, 1, 1, 0, 1, 0, 2, 1, 0, 0. So this is an example which they have calculated with these allocation matrix and request matrix. So for that, if I have tape drives as 4 and A, that is request matrix is 2, plotters are 2, requested is 1, scanners are 3, requested are 0, CD-ROM is 1, requested is 0. So how can I calculate this? So for that, they have got these current allocation matrix and the request matrix which are there. So recovery from deadlock. How do you recover from deadlock? It needs to recover from deadlock when it is detected. Once you are detected with a deadlock, you need to solve it, and to solve that we need a detection solution, that is a recovery. Possible methods of recovery though are not attractive. They are not attractive. Please keep this in mind. Exam questions come like this. Please explain a recovery from deadlock, detection algorithm, conditions of deadlock for occurring, what is the circular wait condition, define the hold and wait condition. So these type of questions occur, so do not get confused. Recovery from deadlock has three conditions: preemption, rollback and killing process. So rather to get recover from deadlock, we need to detect it, and once detection is done, several options exist after detection algorithm detects that the deadlock exists in the system. One possibility is to inform operator and let them decide how to deal with it manually. One thing which you can do is you can go for the system operator and tell that person that yes, there is a deadlock situation, please solve these conditions. The second option is to allow the system to recover from the deadlock on its own, that is the second condition. Now there are two situations exist to break a deadlock. One solution is just to abort one or more processes so that circular wait will be broken, that is the third part, that is dynamically allocation of resources, or fourth one, that is preventing it from one negating the fourth one. So what we will do is we will see all the three, that is preemption, then we'll go for rollback, and then we'll go for killing the process. So the first one is process termination, that is killing a process. We'll go with first one. When deadlock occurs, the operating system decides to kill one or more process. So if my system is asking, there are two processes in my system, and my system is asking for killing the process, the two processes are asking me for same resource. What I can do is either I can give my resource to one process or the another one. If that condition is not there, I can only delete some of the process, that is I can remove one of the process, so that is killing one process, so that resource will be only attempted by the one process. That means this will reclaim the resource acquired by that killed process. The deadlock detection algorithm detects whether deadlock exists or not after killing the process. Following two methods are used for killing the process. Kill all deadlocked processes, kill one process at a time. What it can do is it can have options. Means what? If deadlock is there, whichever resource is creating a problem for deadlock, whichever process is related to that resource, remove that resource, means deadlock is removed. Or else we can do which process requires double resources, we can remove that process at that time, so that deadlock can be removed. So kill all deadlock processes, we'll go with that first one. So there are two types in killing process: kill all deadlock process, and second one is kill one process at a time. So we'll go with first, that is kill all deadlock process. This method is simple and effective to eliminate the deadlock and clearly will break the deadlock cycle. So this cycle can be easily break with the help of this kill all deadlock process, that is the first type in killing, but a huge cost. It will require a huge amount. If all these skilled processes have been performed the computation for longer period of time, then the partially computed results would be wasted. So if people are working for a lot of time on such processes, and if we delete such process, then there could be a loss and wastage of the human intervention also. Recomputation will be done it and is very costly. So if recomputation of such huge amount of data if is done is also very costly. Kill one process at a time. In this method, that is the second method in killing process, in this method one process is killed at a time and detection algorithm is involved in to check whether deadlock still exists or not. So kill one process at a time means killing the process, one single process by which it is creating a problem, and we'll check even if we are removing that process, still deadlock exists or not. So step by step checking that after removing each and every process, does deadlock exist or not, through which we can detect the deadlock. So kill a process, that is killing a process, is also called as process termination. I repeat, kill a process, that is killing a process, is also called as process termination. So different parameters that need to be considered to ensure the minimum cost are, so in killing a process, whatever cost which are incurred, as they have said, it requires huge cost and a huge waste of computation power which is required, a lot of human intervention, that is human power which is required for doing that task is wasted. So what do they require? Priority of the process. If that process is important, we cannot remove that process. We need to generally solve it with the help of resources, that is dynamic avoidance can be done. Second is how much computation process has finished. If that process is working for last 5 years and you directly remove it, it can have a bulk of data and which can be lost. The number of resource process has used. So how many resources are used by that process? It cannot be only one single resource, it can be 100,000, anyone. So the type of resource that the process has used, which type of resource it has used, that is either it has used one only type of resource, multiple type of resource, anything. The number of resources the process we need to complete the execution. Now further, if it has stopped in the deadlock on the fifth resource, but how many further resource it is requiring to complete that task can also be calculated. Next is the number of processes needs to be killed. If that process is getting a problem, how many process related to that single process can be killed, and whether the process is interactive or batch, that is it in the only sequence waiting or it is actually working in the interactive process. We have to check these all conditions or parameters for killing of one process at a time. That is the second type in killing process. Second one is first one is preemption, that is this one. What is the recovery from preemption take? Incrementally preempt the resource from the process and reallocate the resource to other process until the circular weight is broken. So what we can do is, for doing such things, we can preempt the resource. Preempt means which resources can be taken back. So to take those resources and allocating the resources to some another process to get completed, and to do that, by doing this, what we can do, we can remove the circular weight condition, and by removing such circular weight conditions we can solve the problem of deadlock. And it has three types: selecting a victim, rollback and starvation. But we will go only with the rollback process. That is, rollback is after preempting, that is after getting the resources back or resources from a particular process. It cannot continue the execution as needed resources are preempted. It is required to roll back the process to safe state. We cannot directly continue that same resource further to somebody else. We have to check whether there is a problem or not. We have to again restart it. We have to see whether that process is in the safe state or not, and then we can move further. That is, rolling back to the same starting position and then starting it is the condition in rollback. So there are three conditions for recovery in deadlock. First is preemption, that is taking the resource back and providing it to somebody else. Then rollback is starting it from the safe state again, restarting it. We directly cannot give it, directly pass it on for execution. And third one is killing a process, means killing has two types: kill all deadlock processes and kill one process at a time. So kill one process at a time also has different parameters. Please students, please, while you all are writing assignments or when you are going through these videos, please mark these topics and jot it down in your notes wherever you are taking your notes, so that you will understand when you study that these all questions are frequently asked in the exams, in the university papers. I'll be as long providing the questions also, frequently asked questions, or frequently like your last year's papers, so that you can get idea how your exam questions occur, so that you can go through and study. As well as while you are writing the assignments, please do not keep that pages somewhere else. Maintain those assignments, so that while you all are studying for the exams, You can go through those assignments for revision. Next is, so these are the descriptions of your preemption, rollback and killing a process. Those who want can, in this video only, can take the screenshots for referring. Next is deadlock avoidance resource trajectories. So what is deadlock avoidance? What can be done to avoid deadlock? We can just take some preventions so that deadlock will not occur. So two resource trajectories means where it is getting concluded, how we can do that. So deadlock avoidance requires that the system has some information available upfront. So to avoid the deadlock, priorly the system should have some information related to that deadlock. Initially, every process declares the maximum number of resources need which it may require. So initially, every process, when it starts processing, it shows that, or it tells the system that yes, this is the amount of resources which I require. An alternative method for avoiding deadlocks is to require additional information. An alternate method to avoid these deadlocks can be to check additional information about how resources are to be requested, how resources are requested from that particular process. If the sequence in which process will request the resource and will release is known additionally, then we can decide each request whether or not the process should wait. So once if the process tells in the sequence that this is the time when I request the resource, this is the time I will release the resource, and once it requests and releases it, we can decide to avoid the deadlock. We can decide as a part of a user or a system administrator that each request from the process can be wait, we could keep it waiting or not, to avoid the circular wait condition completely. When you want, the major part is the circular wait condition. So circular wait condition can also be avoided. A deadlock avoidance algorithm, so there is again one algorithm that is called as deadlock avoidance algorithm, inspects the resource allocation state in dynamic way. Dynamic and static is, static means it keeps on going with the same process. That is, when I say it should run A to Z, it will run A to Z only. That is static, no changes. Dynamic means which will keep on changing. If I say A to Z, it will run A to Z. If I say A to D, it will run A to D. If I say D to F, it will run D to F. Likewise, dynamically it will keep on changing. That is the, and static means no changes. So dynamic resource allocation states can be changed for deadlock avoidance algorithm to be inspected. Following are the factors which define and describe resource allocation state. So when we are providing resource allocation, what are the factors? The number of available resources in the system. So it will ask you for the number of available resources in your system. Second is the number of allocated resources in your system. How many are allocated to the process, how many are actually available, and the maximum demands of the processes. What this process demands, how, what resources, what type of resources, this process demands which type of resources, the maximum demand what the processes are doing. Banker's algorithm is used for deadlock avoidance. So Banker's algorithm is being used basically for deadlock avoidance. The algorithm requires prior knowledge of number of resources each process needs. So this Banker's algorithm requires a prior information about how many resources are required by a process to get complete. That is a prior information, not after the process completion. After that, the OS act like a sincere small town banker. That is a normal banker, like they have the condition. I will explain the banker's algorithm also in the further topics. OS will allocate the resources to process only if it has sufficient number of resources available to fulfill the possible demand. The OS will only interact if it has that amount of resources, then only, otherwise it cannot fulfill the demands. This is considered as a safe state. Safe state means if it has resource, then only it will respond. If it does not, it will not. So when it has, it will respond. That is called as a safe state. So there are safe and unsafe states. Means if the system is able to allocate resources to each process up to its maximum need in same order and still avoid a deadlock, then the system is a safe state. Means I have resources and I till suppose if I have 10 resource and the system has asked for 6 resource, yes, obviously I can give those resources. So until the time I am able to give the system the allocated resource, the system is able to give me the process resource completion till that time, and in the same like clock, that is 1 to 10, 10 to 12, in the same motion in which the resources are allocated, that is called as a safe state. If the safe sequence of all processes present in the system and the system is considered to be in the safe state, otherwise it's in the unsafe state. See here, 392427, 394427, 390-27, 39077, 3900. Means what? Free is 3, free is 1, free is 5. Means whenever you calculate, each and every resource is getting removed or is not allocated, and because of which, means in the same calls they are going, they are not like getting out of the line, so sequence is being followed, so there is not a problem. So these are all in the safe state. Safe and unsafe states are these also. Demonstration that the state in B is not safe because it is not following the actual criteria, it is getting changed. Here it is 3, here it is 4, here it is 4 again, here it is removed, that is it is following the path, but this is being changed, that each and every block is being changed, and because of which it goes in the unsafe state. With this we'll stop here for this lecture. We'll continue the next topic in the next lecture. Thank you.